Normal forces. The normal force is defined as the component perpendicular to the surface of the contact force exerted on an object by a surface, preventing the object from penetrating the surface. This is an example of a normal force in an elevator. The total mass of the system will be 200 kilograms. The velocity of the system will be 2.0 meters per second downwards. We could then calculate the force due to gravity using the mass times the acceleration due to gravity. The force due to gravity then ends up being 1,962 newtons, which is approximately 2.0 times 10 to the power of 3 newtons. Since the system is not accelerating, the force due to gravity is equal to the normal force. Therefore, the normal force is 2.0 times 10 to the power of 3 newtons. In this example, we have an elevator that is accelerating downwards at 2.0 meters per second squared. We know that Fnet is equal to Fg plus Fn. Rearrange to equal Fn equals Fnet minus Fg. And we sub in Fnet, which is mass times acceleration of the system, and then sub in the force due to gravity, which is mass times acceleration due to gravity. The normal force ends up being negative 1,562 newtons. The negative represents upwards. Part 2. Friction forces. Friction is defined as the resistance that one surface or object encounters when moving over another. There are two different kinds of frictions, static and kinetic. Static is defined as the friction that prevents an object from moving when it is at rest. Kinetic friction is defined as the friction that slows down or stops an object that is already in motion. The equation to find friction is friction equals the normal force multiplied by mu, where kinetic friction is equal to the normal force multiplied by mu k. Mu k is the coefficient of the kinetic friction, and it is unitless. Here's an example of how to find kinetic friction. So we have a mass that is 20.0 kilograms. And we'll throw an applied force on there of 50 newtons to the right. We also know that this mass has a force due to gravity, as well as a normal force, and the kinetic friction force. The coefficient of kinetic friction is 0.5. First we find the force due to gravity by multiplying the mass by the acceleration due to gravity. This ends up being negative 196.2 newtons. And we can tell that the normal force is equal to the negative gravity force. So we know that the normal force is 196.2 newtons, positive. We can now sub that normal force into the friction equation. And we find that kinetic friction is 98.1 newtons to the left. In order to find the acceleration of the system, we find F net, which is equal to the force applied plus the kinetic friction. The F net ends up being negative 48.1 newtons. Due to the friction force being higher than the force applied. We can then rearrange the F net equals mass times acceleration equation to have acceleration equals F net over m, sub in our values, and find that the acceleration of the system is negative 2.4 meters per second squared.